So even though this is a personal finance class, we're actually going to start the year off talking a lot about business economics. And although that sounds like this big, daunting, challenging thing, we're really just looking at the way businesses interact with us, with their consumers, why they set prices the way we do, because that also informs the way that we as consumers interact with those businesses. And that, of course, is going to influence our personal finance, right? The way we budget, the way we plan for investments, the way we plan for large purchases, things like that. So we're going to start actually with a little bit of statistics, talking about some scatter plots and linear regression. And this is rather definition heavy. So bear with me at the beginning here. Our goal here is just to talk about what a scatter plot is and how we can use them to predict future events, and this will actually guide this video and the next video as well. So some definitions. Data is just any set of numbers or values related to a particular subject. The key word here, right, is that that's related to a particular subject. If I just tell you, or if I just give you this list of numbers, that doesn't mean anything. The set of numbers doesn't mean anything until I tell you that they're the set of test grades from a sample of 5 students. And this is a single set of data, so we're going to call this univariate data. This is univariate data. So a single set of data is called univariate, right? Things like test grades. Maybe I talk about just my height. Maybe I talk about the screen time, maybe on my phone over the course of a year. Maybe I talk about the screen time from a whole bunch of people over the course of a week, things like that. Well, if I have univariate data, I also have bivariate data. And bivariate data is shown as a set of ordered pairs that compares by, right, two, so it compares two different pieces of data and shows a relationship between all of the pairs. So maybe I'm comparing height to weight. Maybe I'm comparing study time to my test grade. Things like that. Anything I'm trying to compare two of, that would be my bivariate data. Well, if I have bivariate data, I can show this visually with a graph, and that's where my scatter plot comes in. And all my scatter plot is a graph of isolated plotted points. So the keyword is isolated. I'm not connecting these points. And the whole point of a scatter plot is to illustrate some kind of a relationship among the set of bivariate data. We call this relationship a trend. So if I have whatever my scatter plot is showing, but here are all of my points, well, we can see that there's some kind of general pattern or trend here, right? I can see that most of my data seems to trend upward, right? This is vague, maybe I can highlight it, right? I've got this vague upward trend going on in my data. And that trend is important. We're going to talk a lot about it in this chapter, what we can do with those trends. We call this trend a correlation, and that's just a fancy word that means association between the data's two variables, whether that's x or y. And correlation may, of course, be positive or negative. And in this case, change my color here. In this case, we very clearly have some kind of a positive correlation, right? I have a vaguely upward trend going on. Well, this relationship might actually be causal. So we have a causal relationship if we can explain logically that one variable directly causes a change in the other. Right? So things like height and weight. Right? Generally speaking, as I get taller, I also tend to weigh more. And that would be a causal relationship. One causes the other. So the variable that causes the change is the explanatory variable, and the variable affected is called the response variable. So in this case, with my height and weight, height would be the explanatory variable because it's causing the change. Right? I said the taller I get, the more I weigh. So my explanatory variable is the height, and my response variable is my weight. The taller I get, explanatory, the more I weigh, response. there's always this explanatory and response. However, it is not always the case that when there's a correlation, there is a causation. Right? Just because two things are associated, right? Just because there is some kind of an association, that does not mean that one causes the other. We're going to take a look at this pretty often throughout this section, is that correlation does not imply causation. This is rule number one. Just because it looks like there is a connection between the two pieces in the scatter plot, that does not mean that one directly causes the other to change. There might be other influences at work. So let's take a look at an example. I have this table over here to my right that shows the daily high temperature and the number of water bottles sold over 9 days at a park. So I want to create a scatter plot. I want to know if there's a trend, and I want to conclude whether or not there is some kind of a causal relationship present. So I've got my calculator here, and we're going to walk through how to actually make the scatter plot on your calculator. So the first thing I need to do is actually enter in the data that I've been given, right? I can't plot the points if I don't have the actual values with me to work with. So I'm going to press Stat and then Enter to access this Edit menu. As you can see, I've already got some data in this column, these columns, and this is not the data that I'm working with. So I'm going to arrow up to the name of the column, L2. I'm going to press Clear and then Enter, and I'm going to do that in L1 as well. And now I'm free to begin entering in all of my data. So we're just going to go ahead and do this. It's going to take a minute. 79, 80, 86, 86, 91. Oops. 91, 95, 100. There we go. And I'm going to do the same thing in L2. So 102, 133. So I'm being really careful to make sure that all of my data for one column, or depending on how the table is shown, one row, is in the appropriate column, right? So all of my temperatures are in one column, and all of my water bottle sales are in the other column, and I've got all my data entered in here. So now that I'm done with that, I want to make sure my stat plots are on. So I'm going to press second and then y equals, and you can see that I have like the stat plot menu here. And actually, I already have my stat plot turned on, but we'll go through how to turn it on anyway. So if I need to turn this on, I'm going to press enter, and then I'm just going to make sure, right, I can turn it off, and I can turn it back on. We'll talk about some of these other types of graphs later, but for now you don't need to worry about them. And of course my X list is in L1 because that's where I put my temperatures, and my Y list is in L2 because that's where I put my water bottle sales, so I don't have to change that either, which is nice. Fortunately, our calculator lets us, it will automatically scale the graph for us, so we don't have to do that by hand, and I'm going to do that by pressing zoom and then option number 9 for stat. So I can either arrow all the way down, or I can just press the number 9, and sure enough, whoa, I'm going to get rid of that equation. There we go. And sure enough, here is my scatter plot that shows roughly a positive trend, right? I see as one increases, as my temperature along the bottom increases, my water bottle of the y-axis will also increase. So there's a fairly positive trend here, I would say. We'll talk more in this section and beyond about how to actually express this a little bit more precisely throughout. But for now, it's good enough to say that, yep, I do see a trend here, and I see a positive trend here. So we've shown on our calculator our scatter plot, and we've shown that there's a positive trend. Well, can I conclude that we have a causal relationship? Remember that my temperature is here, and my water bottle sales are on the y-axis. Well, yeah, I would say that there's a causal relationship here. Right? I would say that as the temperature increases, more people are going to be thirsty, and so they're going to want to buy more water bottles. So yeah, I would say that there is a causal relationship here, and then I would say that the explanatory variable is the temperature, which is why it's my x variable, and the response variable is my water bottle sales, which is why it's the y variable. Right? It's like having an independent and dependent variable, like you used to talk about in algebra. Right? My explanatory variable is independent. It can change as often as it wants. Whoops. and my response variable would be my dependent variable in this case. Well, let's consider something a little bit different. If we changed the problem so that daily high temperatures were replaced with lifeguard rescues, so now I'm comparing lifeguard rescues to water bottle sales. And it seems like there's kind of a correlation here. We're going to assume that the graph stays the same. Well, the relationship is no longer causal. I can't say that because more people are getting rescued, that therefore more people are buying water bottles. That doesn't make sense. There's something else going on, right, that is causing these to both change. Well, in this example, it's the temperature, right? As the temperature increases, more people are thirsty. They're going to want to buy more water. But also as the temperature increases, more people are going to go to the beach. And if more people are at the beach, there's a higher chance that somebody will need to be rescued by a lifeguard. So we call this extra third variable, or extraneous third variable, a lurking variable. So this is an extraneous, there's a third variable in a non-causal relationship. That's the key here, which may explain the correlation between the two variables. This goes back to that rule number 1 I talked about before, right? Correlation does not always imply causation, and this is why, right? I can't conclude that an increase in lifeguard rescues relates directly to or causes directly a change in the water bottle sales. But I can say, well, these are both changing together because of the temperature. The temperature is influencing the change in both the lifeguard sales and the water bottle sales. And this is my lurking variable. So here's an example, and actually for the sake of time, we're not going to walk through the entire thing with the scatter plot. You can kind of go back and see how the scatter plot was done. But please, if you need the extra help, this would be a great time to pause and try the problem anyway. But I want to describe the correlation. Is there a causal relationship present? Yes or no? Well, we're comparing students' height to their reading level. And if you look at my scatter plot, right, we have height and we have reading level. There's a vaguely positive trend going on here, and we would be tempted to conclude that, yeah, there is a correlation here and a causation here, right? The taller you are, the better reader you are. Well, that doesn't make a lot of sense, right? Is your height directly influencing your ability to read? If I have height and I have reading level, are these directly causing each other to change? No. Something else is going on behind the scenes. Right, so this is not a causal relationship. It doesn't make sense logically that the taller you are, your height in and of itself makes you a better reader. There's something going on. Well, we're talking about elementary school students. And usually if you're a taller student and a better reader, it's usually because you're older. So a potential lurking variable would be your age. Right? Your age is usually going to make you taller as you get older. And the older you are, the longer you've been in school. So hopefully that makes you a better reader. So age is causing both to change and make it look like there is some kind of a connection, a link between the two.